Hello, this is the lab for the 28th of September 2021 and the 30th of September for 2021, the Tuesday and Thursday lab of LA Harbor College Physics 37 course. Okay, so what we want to do today is first, I want to tell you that the report for lab 1 was corrected and uploaded to your group folder. I'm going to guide you through how you can see your corrections in there, what you did incorrectly, and can fix it for the next lab. Okay, if you're taking the lab on Tuesday, please label your lab report, both the spreadsheet and the Word PDF documents, as P37 TUL02 GY, where Y is the group number. Is your group number. So that would be the lab report that's due today. Okay, if you're taking this lab on Thursday, so relabel it P37THL02GY. And it's okay to have documents of different formats, both Excel and Word and PDF labeled in the same name, so don't worry about that. And please upload these lab reports for the lab number 2 to your group folder. Today experiment is a vectors and force table. Okay, so the first thing that I want you to do is to download the P37 TUL03GY Excel file from my shareable folder in Google Drive. I'm going to show you where it is located. You should have the link for the shareable folder, right? So here you go, you have all sorts of documents here. I want you to download this one right in here, this document right in here to your hard drive. P37 TUL03GY. Okay, I already have it. I'm going to download it myself to my hard drive. Here you go, it's coming. Don't forget to change Y to your group number. Here you go, it's right in here. And I'm going to open this document. In my case, let's say I'm group number 0, right? I'm going to relabel it to G0. In your case, if you're group number 1, relabel it to G1, G2, G3, and so on. Go ahead, open this document. So what you have here is a different Excel spreadsheet now, okay? In the previous 2 experiments, I provided you only with the spreadsheet for lab 1. And then in lab number 2, I provided only with the spreadsheet of lab number 2. Okay, now this one here is a document that has all the spreadsheets, that has all the tables for all the labs that we're going to perform this semester. Okay, so here is the spreadsheet for lab 1, 2, 3. That's what we're going to do today, right? 4, 5, 6, 7, 8, and 9. So that be aware of that. And now, from now on, you don't have to worry. You already have all the spreadsheets for the upcoming labs. Okay. Okay, here you go. Today's experiment is going to be a force table. Okay, here you go. I'm gonna write that down here. This new spreadsheet has the tables for the remaining labs of the semester. Okay. So today's experiment is force table. Okay, we are going to verify the equation for the right angle triangle and demonstrate how vectors sum in real life, right? How vectors are summed in real life. In real life, I mean in the experiment, in real life. The equipment is very simple. It's a force table with a protractor imprinted at its top and an angular resolution of xx dot x degrees. That's the resolution of your the resolution would be half a degree. Okay, the drawing of the first table is something like that. It's a circular table. I didn't put the degrees right in here, but that's how it looks like. You have a graduated scale in degrees on the top, going from 0 to 360 degrees. Okay. A scale, you're going to need a scale to measure the masses that you're going to use, with a resolution of 100 of a gram. Okay. What else do we need? Well, so the resolution of the scale in kilograms would be something like that, and that's how you'd write the values of your masses, right, with the significant figures. What else do you have there? You have 3 mass holders of 50 grams. 4, we have a set of strings, a set of 3 strings attached to a ring, and a pin that goes on the center of this, of the table. Okay, so that's how. Oh, and what else? We have not just the mass holders, but we also have a set of slotted masses of different values that you will use during the experiment to verify the right angle law, the right angle theorem. Here you go. The Pythagorean theorem, to verify the Pythagorean theorem. So those are the things that you have, okay? So, well, let me just review what the Pythagorean theorem is all about, okay? The Pythagorean theorem tells you that if you have a right angle triangle, okay, of, let's say, lengths with a hypotenuse is a length m2, and the other sides m1 and m2, they are related to each other according to this relation. The square of the hypotenuse is equal to the sum of the squares of the sides of the triangle. That's what the relation is all about. If you're talking about forces, right? If we are applying forces, so those m's here should be the forces. If we are talking about vectors, velocity vectors, then those m's here should be velocity or speed, okay? And so on. We are going to verify this theorem in the real world. So what we are going to do, we're going to start with a non-value m1, and this m1 are going to be the masses that are going to hang in there. They are going to apply a force to my string. We are going a non-theta1, a non-m2, and a non-theta2. And then you're going to have to find the m3 and theta3 to verify the Pythagorean theorem. Theta 3 is going to be related to what? Here you go. Theta 3, I'm going to write that down here. Is right in here, what theta 3 is supposed to be, right? Theta 3, the theory predicts that it's going to be equal to m2 over m1. Okay, so let's take a quick look at the setup again. Here you go. here are the table without the masses, without the forces being applied. What you're going to do here, you're going to place a clamp with a pulley with a clamp. So you can add that to the list of equipment, right? Here you go, pulley with a clamp. Pulley with a clamp. There will be 3 pulleys with a clamp. Here's the center of the table. Here are the 3 strings that I mentioned to you, attached to a ring. Okay, so here you go. We didn't have the ring in the previous illustration. Now I'm putting the ring. The ring is already attached to those strings. 1, 2, 3. From these strings, you're going to put mass 1 and mass 2. Mass 1 and mass 2. Okay, so let's say this one is mass 1, this one is mass 2. Mass 1 will remain constant throughout the experiment. Mass 2 is going to be changed. And you have to find mass 3 that will equilibrate those 2 forces, as well as the angle that you have to apply this force. There is a very nice procedure for you to do that. Okay, once you put M1 here and M2 here, the proper procedure would be first to find the angle with your hand. Do not put the masses here at the beginning, okay, initially. Just use your own hand to center this ring in the table to find out the proper angle. Once you find the proper angle with your own hand, then you keep the angle constant and you start to load the mass holder with the slotted masses. That's the proper experimental procedure, okay? Once once we start loading with the mass 3, the ring is going to be centered. Do not forget, because this is the Pythagorean theorem, the mass 1 and mass 2 that are exerting forces 1 and 2 on the ring are going to be, the vector force F1 and F2 are going to be perpendicular to one another. Okay, so we're yielding a resultant force here. And now you have to find a equilibrant force by finding the mass number 3 and its angle. That's basically how the experiment goes. Okay? And in the process, you have to weight everything in the scale. Don't rely on the masses that are written there in the slotted masses. Don't rely. You gotta use the scale to find out the value of the masses that you have there. Okay. So here we go. So M1 is going to be fixed. M2 is gonna vary. M2. So what is the values that we're going to use for M1 and M2? Right here is the. Okay, we do the following. We use those values here, 300 grams for the mass 1. Okay, use 300 grams for the mass 1. And those values for mass 2, 200, 250, 300, all the way up to 450. The angle of mass 1 is 0 degrees. The angle of mass 2 is 90 degrees. So what you're going to do is you're not going to find just one value for mass 3. Actually, you're going to find a range of values. When we do experiments, you never find a spot on data point, right? What you're going to do, you're going to find out what's the lowest possible mass that equilibrate those two here. And then what's the highest mass that will still have an equilibrant force that will cancel the force that those two apply. Okay, theta 3, you're going to find out before you load the mass holder with the slotted masses. Don't forget, the net mass is going to be the mass holder plus the mass of the mass holder plus the masses of the mass of the slotted masses that you load there on the mass holder. So you do, 300, vary here the M2. Okay. And let me show you how you're going to do. You're going to log those values here for M1, the angle theta, that's going to be 0 degrees, right? And M2, the value of M2, and the angle theta 2, that's going to be 90 degrees. So and here is the lower value of the mass. Here's the upper value of the mass. And the angle that you're going to find first. First you find the angle with your hand, and then you find those lower and upper limits of your mass. So this whole table here is the data, the raw data. Everything that you see here is the raw data. And then we are going to process this data. We are going to calculate M2 squared. We are going to take the average value of those two masses, the lower and upper one, and we are going to square the M3 value, the masses, the value of the mass 3. So here, that's where you're going to get your first graph. Okay? So what you're going to do, you're going to plot M3 squared in the y-axis and M2 squared in the x-axis. According to the Pythagorean theorem, when you plot this graph, what you should get, you should get a straight line, right? That's what you're getting. Here is going to be your y. I'm going to here write this formula in terms of the y and x, right? The formula that you're more familiar with. M3 squared is going to be your y, M2 squared is going to be your x. M1 squared remain constant throughout the whole experiment. So you are supposed to get a straight line with a slope 1 and an intercept that's equal to M1 squared. That's your first graph. That's going to be your first graph. So plot, just like it's written in the spreadsheet here, plot M2 squared in the x-axis, M3 average squared in the y-axis. And the second graph that you're going to plot is to verify the angle, right? You're going to plot M2 over M1 in the x-axis and tangent of theta 3 in the y-axis. Here you go. Theta 3, you measure right in here. You are going to get an equation. You're going to get a trend line with the regression equation and the R square. It's a total of, just count how many data points you have here for your graph. You log it in here for both graphs. You go ahead, put your regression equation and your R square for each of those graphs, and then you can get the confidence level, minimum and maximum. For the first graph, you're going to log the slope right here, the slope value right here. Don't forget to put the units. See, the units goes here, the values, the numerical values go here. We do know the slope is supposed to be 1. So here I am taking the percentage difference for this theoretical value of 1. Okay? And the intercept, you're going to log the intercept from your equation. The intercept is supposed to be what? It's supposed to be the square of M1, which would be, 300 grams a square. Don't forget, it has to be in kilograms, right? The mass has to be converted to kilograms. But the intercept, make sure you get the proper unit for the intercept. That's for the first graph. For the second graph, is this one here. All you need is to log the slope. You don't need to put the intercept there. And you get the percentage difference. The slope is going to be, you should expect to be 1. So, and you find out what is the percentage difference, okay? Here, and there. 3 percentage differences. You should expect a percentage, like I said, you should expect a percentage difference of 10% or less. That's what those experiments, that's what you should expect for those experiments. Okay, so I already told you how to get the CL. You can look at the confidence level. You can look at my previous video that I walk you through, right? And good luck with this experiment. Okay, I'll be available with you there in the lab. So looking forward to see you today and Thursday. Bye bye.